Skier moves down a 12-degree slope at a constant speed. What can you say about the coefficient of friction mu k? Assume that the speed is low enough that air resistance can be ignored. Again, this is a typical dynamical problem in which we have friction. So we have to start drawing the picture. Let's say we have slope, we have skier which moves downward over the slope. Just remember that no matter how big your object will be on the picture, essentially this is the point. We're still working with the particle model. Now, all forces you have to show to have free body diagram. So I'll pick a point as my object, as I told you. Doesn't matter how big object is, it's still point in our consideration. Then we have the following forces. We have mg, the force with which person is attracted by the earth, gravity force, it's always downward. We have normal force, which is perpendicular to the surface over which skier moves downward. And because skier moves downward, we will have kinetic friction, Fk, which will be opposite to direction of motion. So we have these three forces. Now, angle here is 12 degrees given to us. I will redraw free body diagram here. So we have mg, we have Fk, and we have n. Now, because acceleration is 0, the skier moves with a constant speed. We have second Newton's law. In general, it has to be written as mass times acceleration equal net force. Net force is sum of all forces acting on the object. And this sum is sum of the three forces we have in our free body diagram. mg, Fk, and n. The order in which you will put the forces is not important at all. Now, acceleration is 0, so we can essentially claim that we have sum of these three forces equal to 0. This is the only dynamical equation we have. But now we have to switch from the vectors to the components. To do that, we have to introduce coordinate axis. I will use inclined coordinate system. X-axis would be along the slope, let's say to the right, y-axis perpendicular. In this case, you see that your n is vertical, your Fk is horizontal, but mg is neither one. So you have to split your mg onto components along the coordinate axis. This is a vertical component, this is horizontal. Now we need to find these components. We know in this triangle the hypotenuse equal mg. Our goal is to find the legs. This is right angle. Now, if you look, you see that in this case, the mg is perpendicular to the lower side of our inclined angle. This side of the triangle perpendicular to the inclined plane. So these two sides are perpendicular to these two sides, and it means that the angles between them are the same. So this is the same angle theta. So this is 12 degrees angle. So I can claim that the vertical component of my force will be equal mg times cosine of the angle theta, and horizontal mg times sine of the angle theta by magnitudes. And now we have to rewrite this vector equation as two independent equations for the horizontal and vertical component. As soon as you split your mg onto horizontal vertical component, you can forget safely about hypotenuse, and you will have 4 error in your picture. So for the x-axis, we have horizontal forces, which is Fk and mg. mg is opposite to the x-axis, so mg is negative horizontal component. So we have minus mg sine theta, this horizontal component, plus positive component Fk equal to 0. And for the vertical axis, we have n, which is positive, and this vertical component of mg force, which is mg cosine theta, is negative because it's opposite to the y-axis direction, minus mg cosine theta equal to 0. Now, whenever you deal with the friction, you always have to add empirical relationship which exist between normal force and friction force. In our case, this is Fk equal mu k, coefficient of kinetic friction, and multiply by the n. Our goal is to find mu k, which we can find from this equation. It would be Fk divided by n. Now n you can find from the equation for the vertical component, so you will have mg cosine theta, and Fk you will find from the horizontal component equation, mg sine theta. You see that mg will be safely cancelled, and you will have sine theta divided by cosine theta, which means that coefficient of kinetic friction coincide with the tangent of the angle theta, tangent of 12 degrees in our case. And if you will use calculator to find this appropriate tangent, you will have value 0.21. This is the value of the coefficient of kinetic friction. We solved problem completely.